Hello Gems! Welcome back to the Super 30 series. In this series, with every video, we are discussing 30 most probable questions for BITSAT 2024. Okay, so this is video number 4. We have already discussed about 90 questions in the previous 3 videos. So if you have missed on that, the links will be available in the description box of this video. Okay, you can check it after you finish with this one. So today's session will be mostly on memory based questions from the BITSAT 2023 paper. Okay, so most of these questions today are going to be from BITSAT 2023 exam. Okay, memory based of course. And yeah, if you want to join this grind, do consider subscribing. And with that being said, let's begin with today's session. Question 1 and 2 over here to start off our session today. So question 1, we have two resistances R1 and R2 with their values given with the error bar. You're supposed to tell the percentage error in their equivalent resistance when they are connected in parallel. Okay, so you are supposed to tell the delta R equivalent by R equivalent. This is the relative error times 100%, right? Percentage error in this quantity when they are connected in parallel. Now in parallel, you have the formula 1 by R equivalent will be equal to the sum of the reciprocals, right? 1 by R1 plus 1 by R2, right? We won't use the product upon sum, it will become slightly complicated because we are supposed to find error. I can differentiate this so that I'll get delta R, right? dr. Okay, so if I differentiate this, I'll get dr equivalent upon 1 by R. The differentiation is minus 1 by R square, right? So minus R equivalent square. Here also the same thing, we'll get dr1 error in 1 divided by R1 square, and here dr2 divided by R2 square, right? So if you can see, you can cancel the minus throughout. And can we generate this quantity? Yes, we can, right? So here we have square, we can take one of the R equivalent to the other side, right? So we'll get dr by dr equivalent. This is the quantity, the relative error for now. We can multiply it by 100 and we'll get the quantity which we are supposed to find, right? So here we can write it as dr1 by r1 plus dr2. Now cancel the negative sign into R equivalent, right? One of the R equivalent is taken to the other side so that it resembles this, right? We want to find this, okay? So now we all have all this value, right? dr1 is this, dr2 is this, r1 is this, r2 is this. What is the R equivalent? They are connected in parallel, right? So connected in parallel, R equivalent will be, you just take the values, okay? These values, okay? Error we are considering over here, so this value will only depend on this, right? So R equivalent will be product upon sum, or you can use this, okay? So 10 into 15 product upon sum, 10 plus 15, 25, right? So this will be 5 3s are 5 5s are 5 2s are, right? So 2 3s are 6 ohms. So 6 ohms is the equivalent resistance. You can substitute all the values over here and you'll get your answer. Okay, you just, I have to also multiply this with 100, right? Percentage error. So we are substituting the values. dr1, dr2 are 0.5 each, 0.5, 0.5. R1 is about 10. So R1 square, right? This is square, sorry. So this will be 100, this will be 2 to 5, 15 square, and R equivalent is 6, and that into 100, right? This 100, okay? So when you calculate this, you can see that you can simplify it a little bit. This 0.5 you can take common. With 6 it will become 3. So 3, and this, if you take LCM, 2 to 5, 100, this 100 cancels with that, and you'll get 3 to 5 on the top, right? So 3 to 5 by 2 to 5 into 3. So somewhat like 4.33 you'll get. Okay, you can calculate this. You'll get the answer to be 4.33%, which is option C. Okay, so this is how you were supposed to approach this question. So a question based on error analysis. Okay, so let's come to this question now. This is based on, I think, the inductance of the coil, so EMI. Okay, so here we have a 12 volts battery. So सबसे पहला काम सुंदर diagram. Okay, so here 12 volts battery, then we have this attached to a coil. Okay, it's a coil of resistance 6 ohm. Okay, so 6 ohm resistance. Then a constant current is flowing. Okay, that is rare for a coil, but it is only for 1 millisecond. Okay, so 1 millisecond the constant current will flow. Then you are going to open the switch. Okay, firstly it is closed, then you open it. You are supposed to tell what is the induced EMF across the coil. Okay, now induced EMF or EMF across the coil is simply given as L di by dt. Okay, or here you can take delta I by delta t since the interval is huge. Okay, so you can use this formula and you can find the answer, right? because if you see what will be the current, first of all, current you can find it as V by R when it is closed. When it is open, it is 0, right? When it is closed, let us find the constant current that is flowing. Okay, so you can find V by R, so 12 by 6, which is 2 amperes. So current is going from 2 amperes, okay, to 0, right? In 1 millisecond, it is going from 2 amperes. Initially, the switch is closed and constant current is flowing, which is 2 amperes. Then it will go to 0 when you open the switch, right? So the change in current delta I is 2 amperes or minus 2, because um, initially it is 0, finally it is 2. Oh, sorry, final minus initial, right? Finally 0, initially 2. Okay, and the time taken is 1 millisecond, or I can write it as 10 to the power minus 3. And EMF induced, okay, the EMF induced is actually given, right? Yes, 20. So 20 is given. So you are supposed to find this L. It's pretty straightforward now. 20 into 10 to the power minus 3 divided by this 2, right? This minus sign will cancel, and you'll have 10. 10 into 10 to the power minus 3. 10 to the power minus 3 milli, right? So this is 10 millihenry, right? Henry is the unit of inductance. So 10 millihenry. Okay, so that is your answer. The question was pretty straightforward based on the formula E is equal to L di by dt. Okay, so that's about these two questions. Over to the next one. 3 and 4 over here. In question 3, we have a boy who is pushing a toy box. He will push it up to a length of 2 meters on the floor by means of a force of 10 newtons. Okay, and this force is directed downwards. Okay, this force is making an angle 60 degrees with the horizontal. I'll draw it for you. So here is the toy box is pushing this with a force of 10 newtons like this. Okay, so this is making an angle with the horizontal of 60 degrees. He will push it up to a length of 2 meters. You are supposed to tell what is the work done. A pretty straightforward question, because work is the dot product of force and displacement, or FD cos theta, right? Excuse me. So force is 10 newtons, displacement is 2 meters, and what is the angle between the two? The angle between the two is 60 degree, right? This is the direction of displacement, this is the direction of force. The angle is 60 degrees. Okay, so cos 60 is half, and here we'll have this cancelling this. Okay, this is cos theta and theta is 60 degrees. Okay, so this will cancel this, and you'll have 10 in the SI units, which is joules. Okay, so 10 joules is the work done by this ball. Okay, so 10 joules, option C is the correct choice over here. Pretty straightforward, direct formula based question, right? So let's come to this one. Here we have a train which is moving with this velocity 10 meters per second or speed. It is approaching a platform and it is honking a whistle which has a frequency of 400 hertz. You are supposed to tell what is the frequency heard by the passenger inside the train. Okay, the speed of sound in air is also given. Okay, and that is not required. If you see, this is a question from Doppler's effect, and I told you Doppler's effect is a very important topic as far as your BITSAT is concerned. It's one of those BITSAT favorite topics, right? So you should not skip on it. So again, here we have a question on Doppler's effect, which is not really on Doppler's effect, because if you see, there is no relative motion between the source and the observer, right? So if you see, the passenger is inside the train and train is moving with this speed. So passenger itself is along with the train moving with the same velocity, right? So there is no relative motion between the two. Okay, so he will hear the same frequency. So frequency heard by this observer or the passenger will be the same, which is 400 hertz, because no relative motion, right? Because there is no relative motion between the source and the, bro was about to say sink, no relative motion between source and sink. No relative motion between the source and the passenger or the observer. Okay, so there is no Doppler's effect happening over here. But if the observer was standing on the platform, then it would have been a different case, right? So then there would have been a Doppler effect, but here there is no relative motion, no Doppler's effect, no change in the frequency. Okay, apparent frequency equal to the original frequency, which is 400 hertz. Okay, so that was testing your concept, but there are questions which are framed on a Doppler's effect. Okay, wherein the frequencies change. Okay, so you are supposed to calculate that too. So study Doppler's effect properly. It's one of the important topic for BITSAT. Okay, so over to the next question. So question 5 and 6 over here. In question 5, we have a capacitor of capacitance C which is charged to a potential V. Okay, you are supposed to tell what is the flux linked with the positive plate. Okay, so you have a capacitor which is charged to some charge q with potential v across it. Okay, so here we are enclosing this plate with some surface. Okay, it's a closed surface. You are supposed to tell what is the flux through this surface. You can simply use your Gauss law. The flux through this surface will be q enclosed upon epsilon naught, right? Q enclosed upon epsilon naught. So q enclosed will be the charge on the positive plate of the capacitor, or the charge on the capacitor, just q upon epsilon naught, right? But here we are given in terms of capacitance and potential V. Okay, so we have to express this charge in terms of C and V, and you know that the charge is simply CV, right? So here phi will be CV by epsilon naught, right? So charge is CV, or you might remember this formula that C is Q by V. Okay, so Q is CV. Okay, so the flux, this is phi, not Q. Okay, so phi is CV by epsilon naught. So basically it was charge enclosed by epsilon naught. Okay, and charge enclosed is CV. Okay, so that was the simple idea around here. So let's come to this one. Here we have a question from units and dimensions. You are supposed to tell what are the units, SI units of A and B. Okay, given that E is your electric field. Here the dimensions of X and Y were not given in the question. Okay, these are memory based questions. They might be given in paper, but maybe somebody forgot to mention them. But okay, here if you see the options, you can see that they will have X and Y will have the dimensions of meters, right? So it will be distance. Okay, so you can make wise guesses like that, although it's not mentioned in the question. Or you can see that electric field in certain region, right? Region is space, so this will be something related to space. Or you can look at the options, that will be better over here. Okay, so let's come to this question. So here we are supposed to find the dimensions of A and B. Okay, so we know that A by x square will have the same dimensions as that of electric field. Okay, okay, so this quantity will be also electric field, this quantity will also be electric field. Two quantities with same dimensions can be added, right? So this and this will have the same dimensions as electric field. Okay, so this will have the dimensions of electric field. So you can see that A will be E into x square. Now what is E? If you see F is equal to QE, right? That is how your electric field is defined. So F by Q will give you E. So you can write this is F by Q, that is E, right? F by Q is E, and this is x square. Now force is in newtons. Now put everything in SI units. So Newton, this is meter square, and this is per coulomb, right? So Newton meter square per coulomb. Okay. Now if you see Newton meter square per coulomb, this is the option over here, right? So you can also verify it for B. B just has one more extra, right? It is one more extra in meters. So you'll have meter cube. Okay. Basically you will have y cube over here, so that will make it meter cube, right? So this is the correct choice. Okay, you can also try by elimination. You can see that A has Newton meter square per coulomb. Okay, none of this matches, right? Only this option is matching, so that should be true for B2. Okay, you can try, that will give you the answer. So that is about question 5 and 6. Over to the next one. So question 7 and 8 over here. Question 7 is from AC ki tesi. Okay, so in this question we are given a circuit. We have LRC. Okay, we are supposed to find the RMS value of the current. IRMS will be simply, you see we have all the components. So we have VRMS by the impedance, right? So Z. Okay, so here you can also see that XL and XC are not equal, so it is not resonance. So you can't replace this simply with a Z or simply with a R. Okay, so here Z will be, have that entire formula XL minus XC the whole square plus R square, right? So here we'll have XL minus XC, which is 200 minus 100, which is 100. So 100 square plus R is also 100, so 100 square. Okay, so this is like a square of side 100, right? So 100 and 100, if you see, it will be 100 root 2, right? So 100 root 2. Okay, so 100 root 2 is the value of Z. Okay, so you can substitute it over here. So 200 root 2 VRMS divided by 100 root 2, which gives you the answer 2. 2 amperes is the RMS current. Let me check that. So 2 amperes, yes. So let's come to this one. Here we have a projectile motion which is projected at an angle of 30 degrees with velocity this. Okay, everything fine up till here. The velocity of projection at t is equal to 2 seconds. Okay, you are supposed to tell what will be the velocity at time t is equal to 2 seconds for this projectile motion. Okay, now I can see a special thing over here. I think this is somewhat like time of flight. So let us calculate the time of flight. You can also do it by the second approach. The approach I'm going to tell you is a different one. You can try resolving this velocity into u cos theta and u sin theta. Okay, so 40 cos theta and 40 sin theta. You can check what will be the value of 40 cos theta will remain constant, right? The velocity along x remains constant. Okay, and what will happen to the velocity along y after 2 seconds. Okay, so you can use the equation of motion and find the velocity in the y direction after 2 seconds. Okay, so you will have vy and vx. Okay, so that will give you, so that you can use the vector laws and you can find the resultant, and that will give you the value at 2 seconds. Okay, or you can confirm if you see. Okay, let's do this method first. So 2u sin theta, this is a different method by g, right? I'm finding out the time of flight because I think this is some special time. Okay, so I may be wrong, but I'm not, because I've tried it. So u is 40 and sin theta is 30, so sin 30 is half, and this is by g, which is 10, so half and half cancels, 10 and 10 cancels. You can see that the time of flight is 4 seconds. Okay, so the total time of flight is 4 seconds. So 4 seconds it will go from here to here. Okay, at 2 seconds it will be at the peak of its journey. It will be at h max. Okay, so t is equal to 2 seconds, we'll have it at h max, and h max you'll have the velocity in the y direction as 0, right? No velocity in the y direction, it is not going up, it is the highest point, right? At that point velocity in the y direction becomes 0, x direction is constant, and that is the only velocity we'll have. So u velocity in the x direction, that is the only velocity, the velocity at 2 seconds. Okay, so this is the velocity which is constant throughout the motion, which is u cos theta, right? So u cos 30, right? So this is 40 into root 3 by 2, right? So this is 20 root 3. So this answer is 20 root 3 meters per second. Okay, you can also verify it by that approach which I told you. Your Vy will come out to be 0 after 2 seconds. Okay, if you use the equation of motion. So you'll be left with Vx, and that will give you Vx as 20 root 3. Okay, so that is our answer. Over to the next question. So question 9 and 10 over here, these are pretty straightforward questions. Usually such type of questions are not asked in BITSAT, but for the paper of 2023, they were apparently asked. Okay, so let's try them out. Here we have two small spheres, okay, with charges this and this. Placed at this distance, you are supposed to tell what is the force between them. Okay, it's very straightforward. You just have to use the formula F is equal to K Q1 Q2 by R square. Right, so here only thing, don't mess up with the units, this is in centimeters. Okay, K is 9 into 10 to the power 9. Okay, this was not mentioned, so that is maybe the catch. You are supposed to know the value. Q1 is 10 to the power minus 7. This is also 10 to the power 2 into 10 to the power minus 7. Okay, so only thing, you don't mess up with the plugging in the values. Okay, substituting the values. And 20 centimeters, so 20 into 10 to the power minus 2 meters, right? Minus 2. Okay, I'm saying not to mess up, and I'm messing up very hard. Okay, so 9 2s are 18, and here we'll have what do we have over here, or I'll not multiply. Okay, why is this taking me so long to do a trivial question? So this is 10 to the power minus 14, and here we'll have 10 to the power 9, and here it is 200, 400, again messing up again. What is happening? This is 10 to the power minus 4, so this will be by 200. Okay, I can say this as, this goes on top, this will make it 10 to the power minus 10, right? Minus 10, and this 9 will make it 10 to the power minus 1, and these two zeros, so we'll have 9 by 2 into 10 to the power minus 1, and these two zeros is minus 3, right? So this is 4.5 into 10 to the power minus 3 newtons. Okay, so option C is correct over here. Okay, so again let's come to this question now. This is also a pretty straightforward question based on the formula. Torque is R cross F. Here you are given the values of R and F. This is F and this is R. Okay, so substitute properly, that is the only thing. So in order to find, you take the determinant, right? So your R is this, so 221, so 221, and your force is 5 3 minus 7. Find it out. I cap minus 14 minus 3, okay, minus j cap, cancel this, minus 14 and minus 5, okay, and k cap this and this, so 2 3s are 6 minus 5 2s are 10. Okay, so here we'll have minus 17 I cap plus this 19 minus 19 plus minus 9 minus 1 more, so that is plus 19, and this is minus 4, right? So option C, if you see, it's correct, right? So minus 17 I cap plus 19 j cap minus 4 k cap, option D, C. Okay, CC. Okay, so that is your correct answer. These were pretty straightforward formula based questions, usually rare at BITSAT, but they were asked, so we did them. Over to the next question. Question 11 and 12 over here. So in question 11 we have a diffraction experiment, single slit experiment of width A. The slit width is A. It is illuminated by monochromatic light. Wavelength is given. You are supposed to find the value of this A for first minimum appears at 30 degrees. Okay, the angle is given for the first minimum. You are supposed to find this A. You can use the condition for minima for diffraction, which is what is that? N lambda is d sin theta, right? D, or here in this case it is A sin theta, right? The width length. So n is, for the first minima, n is 1, lambda is given 600 nanometers, so 600 into 10 to the power minus 9. A you are supposed to find, and sine of 30 degrees is half, right? Half, so this will become 1200 into 10 to the power minus 9, and A. So your A will be, you can shift 3 decimals, 1, 2, 3. So 1.2 into 10 to the power minus 6, or 1.2 micrometer, right, in micron. So here we'll have 1.2 micrometer. Okay, so that is our correct choice. Let's come to this one. Here we have train A and B. सबसे पहला काम सुंदर diagram A and B. So somebody in train A is watching the train B. Okay, it's continuously watching the train B as it is passing, and you are given the velocity of train A is 90 kilometers per hour. Velocity of B is also given. Okay, so velocity of B is 54 kilometers per hour. Okay, so a passenger in train A is watching train B. Okay, he's watching from start till end. Okay, you're supposed to tell, so he's watching it for 8 seconds. So it is taking 8 seconds for train B to pass across the eyes of your train A passenger. Okay, we are supposed to tell what is the length of train B. Okay, so we can break this in terms of relative motion. If you see both of the trains are moving, you can go into the frame of train A and give the velocity to train B, right? What is the concept? You just have to flip this velocity and give it to train B, right? So if you're watching from train A, as in this case, you just have to flip its velocity and give it to the thing that you're watching. Okay, so flip its velocity and give it to this. Okay, so here the velocity will become, so velocity of B with respect to A will become 90 plus 54. We'll consider this direction to be positive. 90 plus 54, that is 100 plus 54, 150. So this is 140, 144. Okay, so 144 kilometers per hour. Okay, we need to convert that in meters. We want the length in meters. Okay, so now what is the next thing? So we know that now we have broken this into a system where train B is moving with this velocity, which is 144 kilometers per hour. Okay, and we are watching from train A. Train A is now at stationary. Okay, because we have given its velocity to the other train. Okay, now we are watching for 8 seconds, right? So it is taking 8 seconds for train B to pass in front of our eyes. Okay, so 8 seconds into the velocity will give us the distance, right? 8 seconds it's taking for train's front end and back end to pass, right? So 8 seconds distance will be speed into time. That will give us the length of the train. Okay, so that is the concept that we are using over here. Just one thing, we have to convert that 144 into meters per second. And how do we do that? 144 into 5 by 80. Okay, if you want to convert meters, so if you want to kilometers per hour in meters per second, then this is the formula. So if you see what will be the answer over here, I can go with 9 1 za, 9 6 za, and 8 za, right? So this is 40 meters per second. Okay, so 40 meters per second is the velocity of train B with respect to A, and finally distance or the length of the train will be speed into time. We are watching it from 8 seconds, so that is 4 3 za, 4 8 za, 32, which is option D. Okay, so I hope the concept was clear. Let's move to the next question. Come to question 13 and 14 over here. Question 13, in Bohr's theory, we are given the momentum, angular momentum of electron in the orbit. Okay, so in the Bohr's orbit, in the first orbit basically is L, and you are supposed to tell if the electron is assumed to move in the second orbit, the change in the angular momentum. Okay, so the first minus the second minus the first. Okay, so in case of your basically your Bohr's angular momentum, quantization of angular momentum says nh by 2 pi, right? Angular momentum is integral multiple of h over 2 pi, or you can write it as nh cut, right? Because h cross is 1 by h by 2 pi. Okay, so in the first orbit, in the Bohr's orbit, it is basically n is equal to 1. So here we will have h cross. In the second orbit, it will be 2h cross. Okay. So here, don't jump to conclusion that this is 2 times L. So the answer should be 2L. Here you are supposed to tell the change, right? So the change will be L2 minus L1. So delta L is L2 minus L1, which is again 2h minus h cross. So 2h cross minus 2h cross minus h cross, which is h cross, and which is nothing but L1, which is L, right? So initially it is L. So here the answer is option C, L. Okay, let's come to this one. Here we are given the Young's moduli of two different materials, A and B, in the ratio 1:4. Cross section area is in the ratio 1:3. If the same amount of load is applied, so F is same, the force applied is same, to two wires, elongation ratio. Okay, so what is the ratio in the elongation? You are supposed to consider the lengths as same. Okay, it was given in the question that length of both the wires are same. Okay, so what is the formula for Young's modulus? It is FL by A delta. Okay, or stress by strain. Okay, stress, force by area, strain is change in dimension to original dimension. Okay, so now we are given that the force is same, so we can write this in terms of force. So Y A delta L by Y A delta L by L. Okay, L is same. So we can equate the quantities in the numerator, right? Or I can write this L on the other side, right? F and L are same for both the Y. So FALA is equal to FBLB. Okay, so I can write Y. I'll just write 1 and 2. 1 means A, 2 means B. Okay, so Y1 A1 delta L1 is equal to Y2 A2 delta L2. Okay, we're supposed to find the ratio in the elongation. So delta L1 by delta L2 will be Y2 by Y1 into A2 by 1. Okay, so Y2 by Y1. So this is Y1 by Y2, right? So Y, the A wire divided by B wire. We have BY. So opposite of that ratio, inverse of that. So 4. Okay, Y2 by Y1 is 4. This is 1:4. So YB by YA is 4. Okay, so similarly, if you see cross section area by A, area of A divided by area of B is 1:3. But here we want B by A. So it is again ulta. So that is 4 3s are 12, and the ratio will be 12:1, which is option B. Okay, so very careful while substituting. It was pretty straightforward. Okay, so that's about this question. We are almost halfway done. With question 15 we'll be halfway done, and yeah, just few things to go. So let's get this done. 15 and 16 over here. In 15 we are given a digital circuit. We are supposed to tell what is the circuit, what is the logic operation that this circuit is performing. Okay, first of all we can simplify this part. If you see, this is a NAND gate followed by a NOT gate. So you are taking a NAND and then you are making NOT. Okay, NAND and NOT, that will give you AND, right? So basically, because NAND gate gives you an output A dot B, the whole complement, and NOT again complement. So complement goes. So basically this is AND gate. Okay, so basically this part is AND gate. Okay, so let's see for the whole circuit now. So here we have an OR gate, inputs are AB, so this will add it, right? Let's come to this gate. This is an AND gate, and inputs are A and B again, so it will multiply it, A into B. Okay, this is again an AND gate. Okay, this is again AND gate. So Y will be, basically it will multiply the two inputs, right? The AND gates basically multiply the two inputs, so A into B into A plus B into A into B. Okay, so now just open up the bracket. So A into A B plus B into A B. Okay, so if you see this, a into ab. So basically we already have a, right? So no point in multiplying it again. So this is simply ab, and here also two b's, doesn't make a difference. It's basically ab. Okay, a b can be 0 or 1. Okay, so that is already accounted over here. So b into b is basically b, right? So here also ab, and here also ab. So a plus a is ab, right? Basically I'm using the law a plus a is still a in boolean case, right? 0 plus 0 is 1, or 1 plus 1 is still 1 in case of boolean algebra, right? So ab plus ab is still ab. Okay, it's not 2ab. Okay, so what is the logic that you get over here? It is AND gate, right? A into b, it is multiplying the two inputs. So basically this whole thing is simply a AND gate. Okay, let's come to this one. Here we have kinetic energy. We are supposed to tell the correct plot of kinetic energy versus the displacement for SHM, and the displacement is x. Okay, um, x is starting from the mean position. Okay, so basically you might know this directly, that the potential energy is proportional to k square. So it's like this. So and total energy is constant, so your kinetic energy has to be like this. Okay, so if you see this part, it is like this. Okay, so option D is correct over here. Okay, or you can also justify it saying that your SHM is starting from the mean position. So for mean position you write a sine omega t, right? For extreme position you get cos. Okay, for mean position it is a sine omega t x. Okay, and v can be a omega cos omega t, right? Just differentiating. Okay, now v will be max when v is max when this term goes to 0, right? Omega t goes to 0, so cos 0 is 1. So omega t going to 0 meaning x will be 0, because sine omega t, sine of 0 is 0. Okay, so v max is a omega, cos omega is 1. So this is the maximum value of v, and it is appearing at x is equal to 0. So velocity is maximum at x is equal to 0, implies kinetic energy, which is proportional to v square, will also be maximum at x is equal to 0. Okay, you can see that this is the only case where kinetic energy is maximum. This is constant. Here it is 0, 0 at x is equal to 0. So these are eliminated. This is constant. It can't be constant because potential energy is varying. Kinetic has to vary in order to keep the total energy constant, right? So it has to be maximum at the mean position and then fall down, right? So that is our correct choice. Over to the next one. To question 17 and 18. In question 17 we are asked for the ratio of thermal energy which is released by, you are supposed to tell the ratio actually for thermal energy released by the parallel combination, not the parallel combination. The ratio of the thermal energy is released in two resistors, R1 and 3R. So R1 is R and R3 is 3R. Okay, you are supposed to tell Q1 by Q2 for this. Okay, Q is basically V square by R into T. I'm using this format because here the voltage is same, right? They are connected in parallel, so voltage is same. So V will cancel, but if you take I square RT, then you have to consider what will be the current in the first one and the second one, and accordingly do it. Okay, here this is a better format to use, right? You can make out from here that Q is inversely proportional to R. Okay, so Q1 by Q2 will be R1 in the denominator and R2 in the numerator. So Q1 by Q2 is R2 by R1. Okay, so basically this will be, oops, I will do this question first. R2 by R1. So R2 is 3R, this is R1, R2, right? So R2 is 3 and this is 1. So 3 is to 1, option A. Okay, let me pick that up. So option A is correct choice over here. Let's come to this one. Here we have an adiabatic process. So the initial pressure and the final pressure ratio, final to initial. So P final to P initial is given as 16 by 81. Okay, you are supposed to find Cp by Cv, which is gamma basically, and you are given that the volume changes from 8 to 27. So the gas is expanding. Okay, so you can use the adiabatic formula. P initial V initial raised to gamma is P final V final raised to gamma. Okay, so I can take P final by P initial, P final by P initial. Okay, so this by this, so V initial by V final raised to gamma. Okay, so this is P final by P initial is given as 16 by 81, 16 by 81, and here V initial by V final, that is 8 by 27, 8 by 27 raised to gamma. Now how will you find this? Okay, we can see that these are very special numbers. So this is 2 to the power 4, right? And this is 3 to the power 4. So I can write this as 2/3 to the power 4, right? 16 is 2 to the power 4. This is 3 to the power 4. Similarly, on the other side, we have 8 as 2 to the power 3, and this is 3 to the power 3, right? So I can write it as 3 raised to 3, and gamma is also there. So this, okay, so you have the bases same, the power should be equal. So 3 gamma is equal to 4, or gamma is equal to 4 by 3. Hence this is hypothetical because such value of gamma does not exist, right? So that was hypothetical. Anyways, the value of gamma that comes from this question is 4 by 3, and that is our correct choice. Over to the next one. 19 and 20 over here. Question 19, we are given that the free space inside your toroid will be filled with certain material of susceptibility this. You are supposed to tell what will be the percentage increase in the magnetic field. Okay, now percentage increase or percentage change is usually given as B final minus B initial, or whatever the quantity is upon initial into 100%. Okay, so final minus initial upon initial into 100%. Okay, this is something that you should remember. So if you see B final, so B dash we'll call it when you plug in your the material, okay, and B initial is just B. So B final will be mu r, so relative permeability times mu naught Ni, right? Because the field of toroid is mu naught Ni initially, right? When you don't have any dielectric, basically it is mu Ni, and if you plug in a dielectric, it becomes mu r times mu naught, okay? And if you don't have a material, it's basically mu naught Ni. So initially it was mu naught Ni without the material. So initially it was mu naught Ni, okay? And this into 100%. So this and this can get cancelled. You can take it common actually. So mu r minus 1 upon 1 and into 100%. Okay. So that will give us the percentage change. If you see, this is susceptibility. Susceptibility is nothing but 1 minus permeability, or I actually remember it as permeability is 1 plus susceptibility, or you can, from here you can write susceptibility is permeability minus 1. Okay, so basically this is mu r minus 1 is 2 into 10 to the power minus 2. Okay, and that into 100, which is 10 to the power 2. So this is basically 2%, right? So the percentage change will be 2%, option A. Okay, take care that the value that is given over here is susceptibility, which is not mu r. This is permeability, relative permeability. Okay, there is a relation between permeability and susceptibility, and using that you are supposed to tell the percentage change. Okay, let's come to this one. Here we have the initial velocity of certain mass being given as a function of time. You are supposed to tell the force acting on this particle at t is equal to 1 second. It is also given as I plus xj. You are supposed to tell the value of this x. Okay, so force is basically rate of change of momentum, right? Or the mass is constant, so m into dv by dt. Okay, so we just have to differentiate and plug in t is equal to 1, right? So m into dv by dt. M is 500 grams or 0.5 kg, we can say. Dv by dt, take the derivative, so 2t derivative is t, and we have I cap, of course, plus 3t square, so 6t j cap, and we have to plug in t is equal to 1. Okay, so 0.5 into 2 I cap plus, when you plug in t is equal to 1, it is 6 j cap. Okay, now if you open that up, this is basically half, right? So this will become I cap plus 3 j cap. So this is the force that we want. Okay, so that will give us, if you see, I cap plus x j cap. X is nothing but 3, option 3, option A, which is 3. Okay, so that is our question number 20. With this, we are 2/3 done with the paper. We are just left with 10 more questions. So let's pull up our socks and let's get that done. 21 and 22, let's keep it rolling. Here we have a proton and alpha particle who are accelerated with 2 volts and 4 volt respectively. You are supposed to tell the ratio of their de Broglie wavelength. Okay, so the lambda of p by lambda of alpha, right? So if you see, lambda is the de Broglie wavelength is given as h by mv, right? H by mv, or that is momentum, or momentum can be written as under root 2 mk. Okay, now kinetic energy here results as acceleration from your potential, right? So in that case, you remember that the kinetic energy will be basically Q into V. This comes from work energy theorem. I think half mv square, you just equate it to QV. Okay, so the kinetic energy will be the acceleration by the potential. So that is Q into V. Okay, so that is the formula we are going to use over here. If you see H is constant, so uh, your de Broglie wavelength is inversely proportional to the mass, and we also have the charge and the potential V. Okay, so here we'll take the root inversely proportional to mass of proton, then we have charge on proton and the potential of the proton. Okay, then we have mass of the alpha particle, charge on the alpha particle, and the potential of the alpha particle. If you see, mass of the alpha particle is 4 times mass of proton, so 4 times mp cancels. Mass on the alpha particles is 2 times that of that on the proton, right? 2he4. Okay, so 2 times the mass, the charge on proton, so 2 times qp cancel. Alpha particle, if you see, is accelerated by 4 volts, this is by 2 volts, so 4 by 2 is again 2. Okay, 4 into 4, under root of that, simply 4, right? So the ratio is 4:1, option A. Okay, I hope the approach was simple, the idea was simple, right? K is QV, that is the main point over here. Let's come to this question. Here we have two identical masses M which are going in circles, okay, due to their mutual gravity, okay, and there is a centripetal force, right, centrifugal as I'll say, okay. So that is balancing them on the circle, so they are going around in the circles, okay, because there is mutual gravity between them, Fg, and there is a centrifugal force, okay. So this basically you are supposed to tell what is the omega, right, the speed of each particle will be, the angular speed actually, okay. Let me check that. The question asks for angular speed, okay, yes. So you know that we have two forces which are balancing each other. One is due to gravity, so I shall write it as F subscript g, and one is the centrifugal force, okay, Fc. Now Fg, the centripetal force, centripetal or the gravitational force is gmm, so gm square, identical masses, by r square. The distance between them is the diameter. Here the radius is given as a, take care, okay, so this distance is a, so the distance between them is 2a, so 2a square, gmm by r square, and centrifugal mr omega square, okay, so m and m will get cancelled. R is basically radius, right, so here a we can write, and what will be omega? Omega, if you see, will be gm by 2 square, which is 4, and this a will come down as a cube, and this is omega square, so under root, okay. Just solve it and you'll reach over here, option C, okay, gm by 4a cube, okay. So you just had to equate the two forces. One is the centripetal and centrifugal. Centripetal due to gravity, centrifugal due to because of the motion, okay, circular motion. So that is about question 22, not 20, that is about question 21 and 22 I wanted to say, and over to the next one. 23 and 24 over here. In 23 we have been given that the magnetic moments of two closely wound coil A and B are equal, okay. You are also given their radius and the number of turns in A and B, current in A and current in B. You are supposed to tell the correct relation between these quantities, okay. So if you see, you might know that the magnetic moment of an electron revolving around an atom is given as Ia, okay. Coils also act the same way because there is current flowing in the coil, motion of electrons in the coil. It will also have magnetic moment, and in this case it will be also Ia, just n times I, because there are n number of turns, okay. So each one is contributing, so n times I into A, okay. So we are given that m1 is equal to m2, right. Magnetic moments of the two coils are equal, so we can write it as Na, current in A, and area of A, so we can write pi Ra square. Similarly, on the other side we can write Nb Ib, okay, Nb Ib, and pi Rb square. Pi cancel, Na Ia will be Nb Ib. If you see Ra and Rb, the relation between them, okay, here also I have Ra square, but if you see, Rb is 2 times of Ra, right, so here it is squared, So 2 times of Ra square. So 2 times of Ra square. So that will become 4 times and Ra square, right? So 4 times Ra square, Ra square cancel. So you'll get this relation, which is option C. Okay, so I just substituted Rb as 2 times of Ra. Okay, and that cancelled out, and here we have this term as 4 times of the other one. Okay, then let's come to this question. Here we have two gases in the flask in the ratio 2:1. By mass, their temperature is that. You are supposed to tell the average kinetic energy per molecule, okay, for this hydrogen and oxygen. Okay, actually it is only a function of temperature. If you see here, the energy of a gas will be F by 2 n kBt, right? Because but you are supposed to tell it per molecule, so F by 2 kBt, right? So if you see, both of them are diatomic, right? Oxygen is O2, hydrogen is H2, diatomic. So F is 5 degrees of freedom, right? So 5 by 2 kBt. So if you see, temperature is same for both, they are in the same class, temperature is same for both. It does not depend on any other parameter, right? So you can say that kinetic energy is a function of temperature, right? Or the energy of the gas is function of temperature only. So with that logic, it is 1:1 and it is correct. Okay, or you can see it the other way around, that velocity will be proportional to, it's actually 3 RT by m, right? So it's inversely proportional to m, if you see, right? Inversely proportional to L and m, sorry, and kinetic energy is half m v square. So if you plug in this velocity as inversely proportional to root m, that m and m will get cancelled. Kinetic energy will come out to be some constant, right? So kinetic energy is constant in this case. It only depends on temperature, and temperature is same for both. So it is, the ratio is 1:1. Okay, it does not depend on your mass ratio or anything else. Okay, so that's about question 24. Over to the next one. Come to question 25 and 26. So in this question 25, we have two radioactive elements A and B. They have initially same number of atoms. Half-life of one is equal to the average life of other. You are supposed to tell the ratio between their lambdas, okay, the decay constant. Okay, so we can use this logic. Half-life of one is equal to the average life of other. So half-life T, half-life of the first one, half-life of A is equal to the average life of B. Okay, what is the formula for half-life? Log of 2 divided by lambda A, right? And what is the formula for mean life? It is 1 by lambda B, right? It's just the ratio, or not the ratio, it's a reciprocal of your decay constant. Okay, so you can see from here that lambda B will be lambda A times ln of 2. Okay, yeah, it was that straightforward. So option C is the correct choice over here. Okay, let's come to this one. Both AB and CD are made of the same material. So this wire AB and CD are made of the same material, have the same cross section area. Okay, pulley are light and frictionless. The speed of wave in AB is V1 and that in CD is V2. You are supposed to tell their ratio. Okay, V2 by V1. Okay, so if you see, we need to know the tension in the string. Okay, because V is nothing but under root T by mu, right? Mu will be same for both the cases. Don't you agree on me on that? Because mu is, if you see, it is mass per unit length, right? We are given that the wire is made of the same material and have same cross section area. Okay, so same material meaning same density, density is same and A is same. Okay, so what I will do, I can multiply and divide by A. Okay, so here and here, okay, I have multiplied and divided by A. So this is volume, right? This area, this is volume, right? Area into length is volume. Mass by volume is density. So this is rho into A. So mu is rho into A, and we are given that they have the same material, they are made of the same material, density is same and area is also same. So mu is constant. Okay, so we can say that your velocity is directly proportional to T. Okay, now we are supposed to tell the velocity ratio V2 by V1. V2 is the velocity in CD, right? So we need tension only. Okay, we already have that. Anyways, so here if we consider it as T, here it also will be T. Okay, because it is the same string, right? So if the tension over here is T, here also it will be T, here also it will be T. Okay, and here if you see, the tension will be twice T, right, for equilibrium. Okay, so T and T in the upward direction, so 2T in the downward direction. For here at the block it is 2T in the upward direction, here it is 2T. Okay, so here for this block in this string CD, the tension is 2T. In the string AB, it is T. Okay, I hope the logic is clear. Here it will be T, so here also it will be T, and here also it will be T. Okay, same string, same tension, and since this is T and T, it will be 2T. Okay, so let's come back. So the tension in the string, so this is directly proportional to T2 by T1. Right, tension in the string T2. T2 is for CD, so which is am I doing something wrong? Because T2 is for CD, right? T2 is for CD, and okay, and this is for T1. So the answer comes out to be root 2, which is not correct. Okay, okay, we were asked for V1 by V2 in the question. I'm so sorry. V1 by V2, right? Yes, we were asked for V1 by V2. So it will be T1 by T2. Okay, just change it. So V1 by V2, so T1 by T2. So T2 is root 2 times T1, you see, right? So this is 2T and this is simply T, T cancel. So you have 1 by root 2, which is option D. Okay, yeah, the logic is correct. The answer is also correct now. Okay, so that is our question. Over to the next one. So question 27 and 28. 27, we are supposed to tell which is the correct figure for your uniformly charged non-conducting sphere. Okay, so for uniformly charged non-conducting sphere, we have the field inside will be proportional to R, right? So if you see, this one is for spherical shell, okay, or conducting sphere, because field inside a conducting sphere will be 0. Later it will shoot up kq by r, kq by r square, and then it will fall as kq by small r square, right? So this is for a spherical shell or a conducting sphere. Okay, so for a non-conducting one, inside the field is not 0, it has some charge inside too, so it is proportional to r, or you can remember the formula, it is rho r by 3 epsilon naught, right? So it is proportional to r, that is what I'm saying. So if you see, this is proportional to 1 by r square. This is like for a point charge. Okay, this is if you see, it's proportional to r inside. Let us see the outside case. The outside case is same as that of a conducting sphere, so it is inversely proportional to r square. Okay, so this is the one that is correctly depicting our non-conducting sphere. Okay, because inside it is proportional, inside the radius it is proportional to r, and outside it is falling as 1 by r square. Let's come to this one. Here we have 8 equal drops of what? 8 equal drops of water, okay, are falling through air and with steady state, okay, and the speed is given as 10 centimeters per second, so that will be the terminal speed. If drop coalesce meaning they collect, okay, to form one single big drop, okay, the new velocity will be, okay, so you can use the concept of terminal velocity, either the direct formula for terminal velocity, or we can use Stokes law, right? Because F is equal to 6 pi eta RV. Okay, we can write this for the small drop, and we can also write this for big drop, and then wisely manipulate and get to our answer. Okay, but also an important thing to note over here is that the volume will be the same. Okay, the volume of the small spheres, 8 small spheres, 8 times the volume of the small spheres will be equal to the big sphere. Okay, so 8 into 4 upon 3 pi r small r cube will be equal to 4 upon 3 pi capital R cube. Okay, so this is for the bigger sphere when they coalesce to form. Okay, so 4 upon 3 pi, 4 upon 3 pi gets cancelled, and your capital R will be square root of this, right? Cube root, sorry. So that is 2, cube root of 8 is 2, and that is 2r. Okay, so the bigger drop is 2 times the smaller one. Okay, now let us apply the Stokes law for your 6 pi eta RV. Okay, for your small drop. Okay, so we can see that the force will be nothing but, basically the force will be 0, right, at terminal velocity, because the force due to its weight mg, the force due to gravity will be balanced by your this force, Stokes force, okay, viscous force. Okay, so these two forces will cancel out each other. So this F is nothing but mg. Okay, that is what I'm saying. Okay, so this is for a single drop. Okay, so that's why I'm writing mg, not 8 mg. Okay, this is for a single drop, small drop. and we have 6 pi eta r v. Okay, now if you see, we can write mg by 6 pi eta r, 6 pi eta r as v. V is given as, for the small drop the velocity is 10 centimeters per second, right? So for big drop, now we can use the same logic. Okay, big drop, the terminal velocity when its weight is balanced by the viscous force, this is the viscous force, so weight is 8 times of mg, right? 8 small drops. This is for single drop, this is for 8 small drops. So 8 small drop, 8 times the mass, right? So 8 times the mass will be balanced by 6 pi eta. Now the radius has also changed. Bigger drop has different radius, of course, and we have found it to be 2 times of 6 pi eta, 2 times of r, or I'll write r dash, or I'll write capital R for the time being, and into v. We are supposed to find this v. I'll write v dash. Okay, so we have 8 mg upon 6 pi eta 2r now, and v dash. V dash is what we are supposed to find. So this is 4 times mg by 6 pi eta r. Okay, we know that mg by 6 pi eta r is 10. So 4 times mg by 6 pi eta r, which is equal to 10. Okay, so 4 times of 10, which is 40 centimeters per second, which is option B. Okay, option B is correct. Okay, logic was simple. You just have to use the Stokes law, or you could have done it, I think, using the terminal velocity formula, but I don't know it. It's a bit large formula. Okay, I think you can also do it that way, but I use the logic of Stokes law. Okay, just balance the weight by the using 6 pi eta r, and you can also equate the volumes. So 8 small drops volume is equal to the 1 big drop, and that will give you the relation between their radiuses. Okay, radii. So that is about question 28 and 29, sorry, 27 and 28. We'll move to question 29 and 30, which will be the last 2 questions for the day. So question 29 and 30 over here. 30 is your homework question. I'll do question 29. So you are supposed to tell which of the following Maxwell equation will not be valid, is valid for time varying case but not valid for static condition. Okay, so actually we can do it other way around. We can see which laws are framed for the static case, and those will be valid for the static case, right? We are supposed to select the one which is not valid. So let us eliminate those which are valid, okay, which are valid for the static case. If you see this one, this is like EDL, right? EDL, this shows the conservative nature of your electric field. It is framed in electrostatics, right, in the first 2 chapters. So EDL is 0, is for the static case. If you even see this one, this is actually E by this is Gauss law, right? Because D, the displacement vector, is nothing but epsilon times E. Okay, that epsilon will go over here. So the flux basically is Q by epsilon naught. Okay, so this also comes in electrostatic. So this also comes in electrostatic. So they are valid in case of electrostatics. They are framed in electrostatics. You see this one, this is actually magnetic field comes due to moving charges, but it's a steady state current. Okay, so if you see, this is also valid in case of your static condition. Okay, yes. So finally this one remains. This one, if you see, it is Faraday's law, right? This is EDL is nothing but your induced EMF, right, or EMF, because EDL gives you EMF, right? So EMF is nothing but rate of change of flux. Okay, so if this was not time varying, okay, if this was not valid for time varying, how will this law be framed? Okay, Faraday's law is itself valid in cases of your time varying cases, right? Because you consider the rate of change of flux, right? Rate of change of flux, the change in flux with respect to time. So it is valid for time varying case, but in case of static conditions, it will not be valid, right? Because there is no variation. Okay, so you can't write, cannot define the change of flux, okay, with a certain time, okay, because there is no variation. Okay, so this is valid in case of time varying case, Faraday's law, rate of change of flux varying in time. So valid in case of time varying case, but not valid for static conditions. Okay, so let's come to this one. This is your homework question. You read it, you do it, and let me know the answers in the comment section of this video. Okay, and that's pretty much it from my side today. Okay, I hope you really enjoyed this lecture, and I hope you love learning like this, and you'll join me in the next sessions, okay, which are going to come up very soon. I think we are going to do about 10 videos, so you'll get about 300 questions. So with this video, we completed our target of 120 questions out of those 300. So yeah, do follow this series. This will help you a lot for your BITSAT 2024. So this channel is a complete goldmine for BITSAT physics. This has everything you need for your physics side of the paper. Okay, so do check out other videos too. Do consider subscribing if you made it this far. So press that like button, and I'll see you soon in the next video. Till then, keep enjoying physics.